हेलो एवरीवन, माय नेम इज़ करण मशरू। वेलकम टू दिस वीडियो। और इस वीडियो में हम देखने वाले हैं कंसेप्ट ऑफ मॉड्यूलर एक्सपोनेंशियल। सो मॉड्यूलर एक्सपोनेंशियल बेसिकली क्या है? सो बेसिकली मॉड्यूलर एक्सपोनेंशियल इज नथिंग बट अप्लाइंग द कंसेप्ट ऑफ मॉड्यूलो ऑन द एक्सपोनेंशियल ऑपरेशन. So this is the exponential operation. So when you do x की power n modulo mod, this is nothing but modular exponential. Okay. So you want to calculate this. Now what will be the brute force approach to calculate this? See, x की power n is nothing but x multiplied with itself n times, right? So what I can do is I can take my answer variable as 1, and for I equals to 1 to n, I can say answer is equals to answer multiplied by x modulo mod. Yes or no? Right? So I can say for I equals to 1 to n, answer equal to answer multiplied by x modulo mod. So this will give me nothing, and before starting this you can also do x is equal to x modulo mod. Okay, so this will give me the required answer, but how much time this will take? This will take big of n time because एक loop लग रहा है. नाउ लेट सपोज आपको x की पावर n कैलकुलेट करना है जहां पे n की वैल्यू 10 की पावर 18 है. तो ये एल्गोरिदम कितने टाइम में रन होगा? मतलब कि आपको x की पावर n मॉड्यूलो मॉड कैलकुलेट करना है. ठीक है, अगर आपको x की पावर n कैलकुलेट करना है जहां पे n की वैल्यू 10 की पावर 18 है और अगर x की वैल्यू 2 3 भी है, देन दैट वुड नॉट बी, यू विल नॉट बी एबल टू स्टोर इन एनी डेटा टाइप, राइट? सो x की पावर n मॉड्यूलो मॉड कैलकुलेट करना है जहां पे n की वैल्यू 10 की पावर 18 के रेंज की है. तो उस केस में ये बहुत एक्सपेंसिव ऑपरेशन हो जाएगा बिकॉज अप्रॉक्सीमेटली आपको 10 की पावर 18 स्टेप्स करने पड़ेंगे. सो व्हाट इज द मोर एफिशिएंट वे आउट? So more efficient way out is this is also known as binary exponentiation because you use the concept of odd and even. Basically binary representation or bit manipulation concept is used here. So how you can calculate this efficiently? For example, let's say the value of n is let's say it is 11. Okay, so you want to calculate x ki power 11. Now what is 11? What is the binary representation of 11? 8 plus 2 plus 1. So 8, 2 and 1, right? So can I also write x ki power 11 as x ki power 8 into x ki power 2 into x ki power 1? This will also give me x ki power 11. Yes or no? So what I can do is I can keep dividing this number by 2 until it becomes 0. So first of all it's 11, then it will become 5, so it will become 101, then it will become 2, so it will be 10, and then it will become 1. And every time I will check the LSB bit. So first time this would be the LSB bit, then this would be the LSB bit, then this 0 would be the LSB bit, and then this 1 would be the LSB bit, and then it will become 0, so we will stop. Okay, now whenever the LSB bit is 1, okay, it means with respect to that bit, whatever is the value of that bit in the original number, that much power we need to multiply. इसका क्या मतलब है? फॉर एग्जाम्पल यहाँ पे इस बिट की वैल्यू 1 है, सो x की पावर 1. इस बिट की वैल्यू 2 है, x की पावर 2. इस बिट की वैल्यू 4 है बट ये 0 है. इस बिट की वैल्यू 8 है, तो 11 में 8, 2 और 1 कैलकुलेट होंगे. x की पावर 11 में x की पावर 2, x की पावर 8 एंड x की पावर 1 आएगा. सो ये बिट की वैल्यू 8 है और ये 1 है, सो मल्टीप्लाइड बाय x की पावर 8. सो दिस विल बिकम x की पावर 11, राइट? सो व्हाट आई कैन डू इज आई कैन टेक वन आंसर वेरिएबल इनिशियलाइज्ड विथ 1. अब इस बिट की वैल्यू क्या है? 1. मतलब अगर मैं LSB देखूं तो इस बिट की वैल्यू 1 है, तो इस टाइम पे x की वैल्यू मैं ये रखूंगा. इस बिट की वैल्यू क्या है? 2. तो इस टाइम पे मैं x की वैल्यू x² रखूंगा. इस बिट की वैल्यू क्या है? मतलब वैसे ये 0 है बट वैसे इस बिट की वैल्यू क्या है? 4. तो जब मैं इस पॉइंट पे आऊंगा, मतलब मैं n को डिवाइड बाई 2 कर रहा हूं एवरी पॉइंट पे, तो जब मैं इस पॉइंट पे आऊंगा तब मैं x की वैल्यू x की पावर 4 रखूंगा, एंड जब मैं इस बिट पे आऊंगा तब मैं x की वैल्यू x की पावर 8 रखूंगा, right? So idea is I'll keep dividing the number by 2 and I'll keep multiplying x with itself. So x will become x square, then x square into x square will become x ki power 4, and x ki power 4 into x ki power 4 will become x ki power 8, right? And whenever the LSB is 1, at that time I will multiply the value of x with answer. So my answer is 1. Now this bit is 1, so I will multiply answer with x की power 1. So answer is equal to x की power 1. ठीक है? Then we will come to this step. अब यहाँ पे x की वैल्यू x स्क्वायर हो गई होगी और ये बिट भी 1 है, सो आई विल अगेन मल्टीप्लाई इट विद वॉट एवर बी द x वैल्यू इज x स्क्वायर, राइट. Then I will come to this step. At this step x value is x की power 4, but this bit doesn't contribute, so I will not multiply with the answer. Then when I will come to this step, x की value x की power 8 है and this bit contributes, so I will multiply it with x की power 8. So my answer would be x की power 11. और इसमें टाइम कॉम्प्लेक्सिटी कितनी लगेगी? We keep dividing the n by 2 until it becomes 0. So time complexity would be big of log n base 2. ओके, तो अगर मैं सूडो कोड लिखूं तो क्या आएगा? आंसर इज इक्वल्स टू 1. ठीक है, इसको बाइनरी एक्सपोनेंशियन भी बोलते हैं. ठीक है, एंड वाइल n is greater than 0, if n modulo 2 is 1, it means if the LSB is 1. Okay, you can do this or you can also check like this. If n and 1 is 1, right, or if n and 1 is greater than 0, right, you can do like this also. So you want to check whether LSB is 1 or not. So if n modulo 2 is 1, in that case I will multiply the value of x with the answer. So answer is equal to answer multiplied by x. And before moving to the next step, I want x to be multiplied with itself, so I will say x is equal to x square and I will divide n by 2. So n is equal to n by 2. So this will take big of log n time and finally you can print or return the answer. Now this method is known as binary exponentiation. In this method, as soon as you apply modular, this is modulo exponentiation. So basically here when you say answer is equals to answer multiplied by x modulo mod, and you say x is equals to x multiplied by x modulo mod. Okay, so when you replace this line with this line and this line with this line, so that you can apply the modulo operation so that answer remains within a range, this becomes modular exponentiation. And यहाँ पे कुछ modular apply करने की जरूरत नहीं है. You can keep dividing n by 2 until it becomes 0. Okay, so I hope आपको ये method clear है. Log n time वाली, this is called binary exponentiation, and when you apply modular operator on that, this is called modular exponentiation. अब इसको कोड करके देखते हैं. Okay, so let's write the code. So let me make a new file and I will say modular exponentiation.cpp. let me like this. So I will say include iostream using namespace std. I can say int main, right? I will take int x and answer is equals to 1. X and I will take from the user. Okay, and you also need a mod. Okay, so mod, let's take it some value. Let's take it 13. Okay, so now what you want is you want x की power n modulo mod. So while n is greater than 0, if n modulo 2 is 1, answer is equal to answer multiplied by x modulo mod, and at every step you can say x is equals to x square modulo mod and n is equals to n divided by 2, and finally you can print the value of answer. Okay, now let's save it and let's take an example. Okay, so let's say I want to calculate 3 की power, let's say what we can take, because I also want to cross verify, so let's take a small value, 3 की power 5 modulo 13. So this would be what, 3 square 3 cube into 3 square modulo 13, right? So 3 square is nothing but 27. 27 modulo 13 is 1. So 1 into 3 square modulo 13, that's 9 modulo 13, that would be 9, right? So the answer should be 9 in case of x is equal to 3 and n is equal to 5. Okay, so this is modular exponentiation.cpp minus o modular exponentiation.out. Okay, so I have got out file, so let's run that. So modular, okay, now it's it wants input from me, so x is equal to 3 and n is equal to 5, and you can see we have got the answer 9. I hope you have understood this concept fully. Thank you.